Hi, everybody. So I'm getting a lot of questions about these 3 by 3 systems of linear equations. So I thought I'd make another video just working out a couple more examples for you guys. So we are going to start with example 3 on this one. And we're going to solve this 3 by 3 system using elimination, just like we did in the other videos. So we're going to take our 3 by 3 system, we're going to separate it into 2 pairs, and then we're going to eliminate the same variable in order to get a 2 by 2 system. So as usual, I'm going to label these as my equations 1, 2, and 3. And I want to try to separate these into 2 different pairs. All right, so I always like to kind of look ahead and decide what variable maybe looks the easiest to eliminate. So looking at my different equations here, okay, I can see already that in equations 1 and 2, we have a negative 3z and a positive 3z. So since those are already opposites of one another, that's going to be a pretty easy variable to eliminate. So I'm going to go ahead and put those two together to start with. Okay, so that was my equation 1 and 2. Okay, let's go ahead and just eliminate that variable. So we're just adding those up. Our z's cancel. We'll get a 4x plus 3y equals 4. And that's going to be our equation A. All right, so we put our one pair together, eliminated the z, got our equation A. So now we need another pair of equations, and we have to eliminate the same variable. So since we eliminated the z in this first pair, we have to eliminate the z in the next pair. So we can either pair together equations 1 and 3, or we could put together equations 2 and 3. Honestly, either one will be about the same difficulty level, so I'm just going to put together equations 1 and 3 because we already have the negative in one equation, the positive in the other equation, so they're opposite signs, maybe a little bit less work that we have to do along the way. Okay, so that was our equation 1 and 3. All right, so now we're trying to eliminate the z variable. So if we were to multiply the top equation through by a positive 2, we would get a negative 6z and a positive 6z, which would cancel out. So times a positive 2 on top. And go ahead and just rewrite this. That becomes 2x plus 8y minus 6z equals negative 16. And just copy that other equation down. All right, and then add them up. So of course our z's cancel out as we planned, and then just add the rest of it. So we get a 3x plus 9y equals negative 15. And that is our equation B. Okay, so putting together equations A and B now, we have our 2 by 2 system. Okay, so our equations A and B together give us our 2 by 2 system. And now we're just going to keep going with elimination further. So we want to keep eliminating. So it looks like the y variable is going to be pretty easy to eliminate here. We just need to multiply the top equation through by a negative 3. All right, so that would be a negative 12x minus 9y equals negative 12. And then just add our equations together. All right, so if we add those up, we're going to get a negative 9x. Our y's cancel, and that equals a negative 27. All right, so if we divide by 9 on both sides, we'll end up with x is equal to 3. All right, so we have our first variable. All right, from here, we just need to start back substituting in order to solve for the other variables. So once you find your first variable, go back to one of your A or B equations, okay, either one is fine. Go back to either of those A and B equations, plug in your x, and solve for y. So I'll just pick B. All right, so we would have 3 times 3 plus 9y equals negative 15. So 9 plus 9y equals negative 15. Subtract the 9 over, and we get 9y is equal to negative 24. Divide by 9 on both sides. So negative 24 over 9 would reduce to negative 8 over 3. So that is our y variable. All right, and then the last step, now that we've solved for 2 variables, is to go back to one of our original 1, 2, or 3 equations, plug in what we just found for the x and the y, and solve for z. Okay, so I'll just pick equation 1. It doesn't matter which equation you plug it back into, you will get the same answer regardless. Let me shrink that so I can actually see it here. Okay, so we have x plus 4y minus 3z equals negative 8. Okay, and of course just plugging in 3 for x and negative 8/3 for our y. All right, so this would be 3, and then that would be minus 32 over 3 minus 3z equals negative 8. Adding up the 3 minus the 32 over 3, where 3 is a 9 over 3, so 9 over 3 minus 32 over 3 is a negative 23 over 3. Okay. Adding the negative 23 over 3 over to the other side, we would end up with negative 3z. So adding 23 over 3 to the negative 8, a negative 8 would be a negative 24 over 3, so that would come out to a negative 1 over 3. And then dividing by a negative 3 on both sides would leave us with a positive 1/9. All right, so putting our final answer together, our x, y, and z, we have 3, negative 8/3, positive 1/9. All right, so that is our final answer. All right, let's do one more just to make sure that you guys are really understanding these. So problem number 4, as usual, I'm going to label these as equations 1, 2, and 3. And we're going to separate them into 2 pairs and eliminate the same variable in both pairs. So again, kind of just looking ahead to see what variable might be easy to eliminate. Okay, it looks like, well, there's actually several variables on here that are going to be pretty easy to work with, but I'm liking the y's. Those look fairly simple to work with. So you have a positive 2y and a negative 2y. So I'm going to start by putting together my equations 2 and 3. That was my equation 2 and 3. And we can just add those up right away. Our y's cancel. And we would get x minus 2z equals 0. All right, so then we need another pair. So remember, we have to make sure we eliminate the same variable again for the second pair. So since we eliminated y the first time, we have to eliminate y again the second time. So I'm liking equations 1 and 3 because we have the positive and the negative, so those will be pretty easy to work with to eliminate. So equation 1 and equation 3. And I've said it before, but just remember, no matter what equations you put together, as long as you eliminate the same variable from both pairs, you will get the same answer. Your process might look a little bit different than what you're seeing here, but you'll get down to the same thing in the end. Okay, so if we're trying to eliminate our y variable again, we're just going to need to multiply that top equation through by a positive 2. So then this would become 4x plus 2y minus 6z is equal to 0. All right, add our equations up. The y's cancel, and we'll have 7x minus 9z is equal to 7. Okay, so these are going to be, that's our A equation, and then this is our B equation. All right, so now putting together our equations A and B, we have our 2x2 system, and we just keep going with it as we've been doing. Okay, so once you get your 2x2 system, you can solve it with either substitution or elimination. Typically, I generally prefer just to keep going with elimination just so that I just kind of get in the rhythm of eliminating and I don't have to switch back and forth between different methods. But if you prefer to switch to substitution at this point, you certainly can. So if that's your preferred method of solving these systems, then definitely go ahead and use substitution. Okay, I'm going to go with elimination. And I think probably the x variable is going to be the easier one to eliminate. And we'll just need to multiply that top equation through by a negative 7. Remember, our goal with elimination is to get the exact opposite coefficient on the top and the bottom equation. So with a positive 7 on the bottom, we want a negative 7 on the top so that they'll cancel out when we add them. All right, so then the system becomes negative 7x plus 14z is equal to 0. And then we still have our positive 7x minus 9z is equal to 7. All right, add those up. Our x's cancel. And we're going to be left with 5z is equal to 7. And then just dividing by 5 on both sides, we get z is equal to 7 over 5. All right, so that's our first variable. Now we just need to back substitute in order to solve for the others. So once you have the first variable, go back to either your equation A or B in order to solve for the next one. So I think A looks a little bit easier to work with on this problem. So I'm going to plug what I just found for my z into that equation. And if we solve that out, we would just get x is equal to 14 over 5. And that's just multiplying the 2 by the 7 over 5 and adding that over to the other side. All right, and then lastly, we go back to one of our original 3 equations, the 1, 2, or 3, and plug in the 2 variables that we found so far in order to solve for the third. So I'm just going to go with my equation 1. Looks a little bit easier. Remember, no matter what equation you plug these back into, though, you will get the same answer. That's the whole point of a system, is that we're finding a solution that works for all 3 equations simultaneously. just plugging in my x and z. Okay. Now we're just going to solve this out. Okay. All right, so we would have here, this would be a 28 over 5 plus y minus 21 over 5 is equal to 0. Combining our like terms, we would have a, what would be 7 over 5 plus y is equal to 0. So subtracting that over, y is equal to a negative 7 over 5. All right, so now just putting our variables together, our x, y, and z, we have 14 over 5, negative 7 over 5, and positive 7 over 5. And that is our final answer. All right, guys, so I hope this helps you understand these 3x3 systems a little bit better. I still haven't worked out all of the examples. There are still a few more in the notes that you can take a look at, but hopefully seeing these extra couple worked out helps you with this. If you still need to see more, just send me an email and I'm happy to go through more examples.